A man runs at a speed of 4 meters per second to overtake a standing bus. When he is 6 meters behind the door, the bus moves forward and continues in the constant acceleration of 1.2 meters per second square. The man shall gain the door at time equal to. Okay, see, since that we have discussed relative velocity in detail, wherein we have solved almost, we have used traditional methods as well as methods using relative velocity to solve the questions. I will do the same here. First, we'll try to solve this question using the traditional method, and then we'll try to solve it using the relative velocity. So, let us first assume the case of traditional method here. So what I'm going to do is I'm going to draw a couple of diagrams to explain the concept. So let us assume that this was the first position of the man, right? So this is the man, and let us assume this to be the bus. Okay. Now let us first understand the assign the corresponding variables. So this is velocity of man and velocity of bus, and we have distance moved by man and distance moved by bus. Okay. So what happens is initially the bus is at rest. So initial velocity of bus is at rest. Okay. And here it is the acceleration is 0, which means this the man is moving with a uniform velocity with of vm. Okay. So what happens after some time? See, so let me mark this as the man's position for reference and this as the bus position for reference. Okay. So after some time, what happens is, say for example, the man reaches here, right? And the bus was at rest, but it starts to move forward with an acceleration. So say for example, the bus reached here. Okay. Then even after some more time, what happens is the bus is still moving, but the man has gained access to the bus, right? So I think it would be better if we draw it like this. So the man has now access to the bus. In which case, what is the distance moved by the man? See, the man was initially here. Let me mark that as A. And the man has now traveled this far and he has reached here, which I'll call it as C. Okay. So AC is the distance traveled by man, right? I'll explain it once again. So the man was initially here. He traveled this long to overtake the bus or to reach the bus. So this much distance is AC. And what is AC? What does AC represents? AC represents nothing but the distance moved by the man, which I have denoted here as SM. Now, let us talk about bus. So let us take this position as P, right? So the bus was, this was the initial position of bus because it was standing. So this is the initial position of bus, and the bus has moved so far. It has moved from B to C. So the distance moved by bus is BC. So let me write here that as BC. Now what is BC equal to? We have termed it as to be SB. So BC is equal to distance moved by the bus. All right. Okay. Now let's see. See, AC, we should understand from the figure is nothing but AB plus BC, right? Now what is AB? See, AB, if you understand here, is the initial position of bus. Sorry, A is the initial position of man and B is the initial position of bus, which means AB is the difference between the initial positions of man and bus, which is given into the question as 6 meters. Once again, A is the initial position of man, B is the initial position of B, which means AB is the difference between the initial positions of A and B. Difference between the initial position of man and bus, and difference between the initial position of man and bus is given according to the question as 6 meter. So we can write that AC is equal to, what is AB? AB is 6 plus BC. Right. Now what is AC? AC is distance moved by man is equal to 6 plus, what is BC? BC is distance moved by the bus. All right. Now let us see what is AB and SM and SB respectively. See, SM means the distance moved by the man. So what is SM is equal to? SM is equal to velocity of man into t. Why? Because the acceleration of the man is said to be 0. In which case, what do we get? SM is equal to what is velocity of man? It is given as 4 meter per second. So we have 4 into, we don't know the time, so that is t. Let the time be t. What is SB? What is SB? See, SB is equal to distance moved by the bus. So SB will be equal to, equation is UB into T plus half into UB into T square, right? Now, since the bus was standing in the standing position initially, so UB is equal to 0, which means that term will get eliminated. So what we have is SB is equal to, what is UB? Velocity of the bus, not UB, it should be AB. So what is AB? AB is 1.2 meter per second square. So that becomes 1.2 into t square by 2. Therefore, SB now becomes 0.6 t square. Right? So we have found out SM, we have found out SB. What can we do? We can substitute in this equation. And when we do that, what do we get? What we get is SM, which is 4t. I think it would be better if I write down this equation once again. So I'm writing down this equation once again. So SM is equal to 6 plus SB. What is SM? SM we have found it out as 4t is equal to 6 plus. What is SB? SB is 0.6 t square. Now, if this is the case, what do we have out of this? What we have out of this is nothing but a quadratic equation which looks like 0.6 t square, right, minus 4t plus 6 is equal to 0. So to make this more simple, let us multiply this by 6, 10. So this becomes 6t square minus 40t plus 60. So 0 is equal to, dividing this by 2, what do we get? 3t square minus 20t plus 30. Okay, this is the required equation. And here what we can do, we can find this by x is equal to minus b plus or minus root of b square minus 4ac by 2a. So what is b here? B is minus 20. What is a here? A is 3. And what is c here? Is 90. So what do we get? X is, okay, we'll solve the value of x later. Now let us solve the same question using the method of relative velocity. So when we use relative velocity, what I'm trying to say is, instead of considering the motion of two objects, we will consider one object in motion with the velocity of other and the other being at rest. Some students may find this difficult. If you're not watched the videos on relative velocity, I've explained it in much detail, so you can try watching the videos there. But anyway, I'll just explain the concept here once again. So what I'm going to do is, we have a man moving with initial velocity um and bus with initial velocity ub, right? Which is actually equal to 0, which doesn't matter here. We are just trying to understand the concept here. So what I'm trying to do is, instead of considering both the bodies under motion, what we can do is, we can consider just one object in motion, but this time not his velocity, but his velocity with respect to the bus. Okay, and the distance between them remains the same. So what here we call is, this is UMB is what we call as the relative velocity, right? And since there is acceleration here, we consider this object moving with acceleration of man with respect to p. Okay, now the idea will become more clear when you try to understand how the solution is done. So it goes like this: initial velocity of man is given to be 4 meter per second. Initial velocity of bus is given to be 0, which means since both of them are in the same direction, in relative velocity of man with respect to b is umb, which is equal to um minus ub, which is equal to 4 minus 0. So relative velocity, okay, or else I think it's better we write umb. So umb is equal to 4 minus 0 and umb is therefore equal to 4. Now similarly, all other aspects of the motion will be taken in the relative conditions, which means acceleration of man is equal to, according to the question, is 0. Acceleration of the bus here is given to be 1.2 meter per second square, 1.2. So what is acceleration of man with respect to b? Acceleration of man with respect to b is acceleration of man minus acceleration of b of bus. So a and b will be equal to minus 1.2. Right? So we have u, we have a. Now the equations of motion apply to the object moving with relative velocity. What would that be equal to? S is equal to ut plus half at square, but instead of s, what do we consider here? S, relative displacement, remains the same, which umb into t plus half amb into t square. What is the distance between them? It is given in the question to be 6, which is equal to, what is umb? It is 4 into t plus half into, what is amb is minus 1.2 into t square. Now if we try to solve this equation, what do we get? 6 is equal to 4t minus 0.6 t square. So this is equal to 0.6 t square minus 4t plus 6 is equal to 0 is the equation that will give us the solution for the time. Is this same as the previous equation? 6t square minus 40t plus, okay, so 0 is equal to 6t square minus 40t plus 60. Yes, this is the same equation. So this also will give you the answer to the time. So we have solved the one problem in two different ways. So let us now come back to the solution here. So what is x is equal to minus b? What is minus b? 20 plus or minus root of, what is b square? 20 square, which is 400 minus 4ac. 4 into a is 4 into 3, 12 into c is 12 into 30 is 360. The whole upon 2a, a is 3, so this becomes 2 into 3, 6. So x is equal to 20 plus or minus root of 400 minus 360 is 40, the whole upon 6, right? So 40, I can write it as 2, 20, 2, 10. So x is 20 plus or minus root of 2 into 2 into 10, the whole upon 6. So x is equal to 20 plus or minus root of 4 into root of 10, right? Whole upon 6. So x is equal to 20 plus or minus 2 root 10 by 6. If you divide the whole expression by 2, 20 by 2 is 10, plus or minus 2 by 2 is 1 into root 10 by 6. Okay, now root of 10. So see, 3 square is equal to 9 and 4 square is equal to 16, which means definitely the root is between 3 and 4. So 35 square is 1225. So 3.5 square will be 12.25, which means the value is between 3 and 3.5. Logically, it should be very close to 3.3. So let us take a 31 into 1 is 31. 3 ones are 3. 3 3s are 9. Yes, so 961. So it's approximately equal to 3.1. approximately. In which case, what is x is equal to? X is equal to 10 plus or minus 3.1 by 6. Now, when we say 10 plus or minus 3.1 by 6, what do we get? X is equal to either 13.1 by 6, or x is equal to 10 minus 6 would be 10 minus 3.1 would be 10 minus 3.1 would be 6.9, right? Oh, sorry, 10 minus 3.1, right? 10 minus 3.1 would be, yeah, 6.9. So, either 6.9 by 6, in which case x is equal to, oh, I made a small mistake here. This is not 6, right? Instead of 6, it should actually be, it should be 6 by 2 is 3. So, it should be 3 here, 3. Here also it is 3. So, we have 3.1 by 3, which gives the value to be either 13.1 by 3. So that will be somewhere around 4.43, 13.1, 4 3s are 12, 4.3 this are 9, 11 minus 9 is 2, okay, 4.3, or x is equal to, 3 2s are 6, 9 3s are 9. So we get two values, x equal to 4.3 almost, and x equal to 2.3. And what is x here? X is time, right? So we get the value of t is equal to either 4.3 seconds, or it is equal to 2.3 seconds. Let us look at the option now. Okay, so well, actually this question is a bit confusing in terms of option, because both options are given here and both of them should ideally be correct. Now, if you ask me the explanation for both of them, why both of them are correct, I'll give you the picture clarity for that process too. See, so here is man, so this is man and this is bus, right? So when we say there are two possible values of time for man beating the bus, it simply means that since the bus is having some acceleration and the man is going with uniform velocity, at some point of time here the man will beat the bus, right? And after that, what happens is the bus is still having acceleration, the bus will move forward, and the man will now be back in the will be behind the man. After some time, so this is bus again, this is man again, and after some time what will happen is the man will again overtake the bus. So this is the possible explanation for we getting two values of